My name is Kiah Imani. I work in developer advocacy, which basically means that I live at the intersection of product and community. I also have a background in engineering, which means that I've had my fair share of deploy and pray moments in the cloud as well. And I also moonlight as a founder. And that's not all of those reasons are why this story resonates with me and why I chose to share it with you all today. What I love most about my role in DevRel is hearing stories like Maya's, and not just because she's a founder, but because these type of stories cut through the hype. Cloud development isn't just about shiny architecture diagrams, but that is part of it. But it's about real people wrestling with real problems and figuring out how to keep going when the going gets tough and adversity strikes. So here's what we're going to go through together. We'll start with Maya's big leap into serverless. Then we'll dig into the struggles that she faced and break those down into lessons. From there, we'll look at her turning point, the moment she discovered local first tools. And after that, I'll show you a quick demo so that you can see what these tools look like in action. Finally, we'll wrap up with the payoff and how she went from almost rage quitting and like crumbling her business and disappointing her investors to building confidently in the cloud. And we will have time for Q&A. So finally, I will wrap it up with some Q&A. How does that sound? Good? Sweet. All right. So back to Maya. Maya just closed her seed round. Her SaaS worked very well. But scaling it meant that she needed to hire an ops team, which even though she closed her seed round, she really couldn't afford. Serverless looked like the perfect answer. It was going to be pay per use, automatic scale, and no ops overhead. Her investors loved it too. It was going to be lean, modern, and cloud native. And she was going to go with AWS. So Maya bet the company on serverless, and that's where her journey began and almost ended. So, a quick temperature check. I'll start with a poll. It's actually, let me go ahead and start interaction. I know there are polls here, but it makes it, oh wait, here we go. It makes it easier for me to kind of get an idea of who's in the audience for reporting purposes later. So if you don't mind, scan the QR code with your phone and answer the quick poll question. What frustrates you most about building in the cloud? Is it slow deploy cycles? Is it debugging blind? Is it surprise builds? Or is it just deploy failures in general? And if it's something totally different, put it in the chat. I'm interested to know. Aha, I've got some surprise AWS bills. Yep, the coins, the dinero, it'll do it to you every time. And all of the above. Yep, Michael, I could totally agree with you on that. I could feel you. I feel you in my heart. Cool. So we've got a bunch of pain points here. Let's talk about those. Let's unpack that, you guys. So Maya's first wall was feedback time. Every change meant a full cloud deploy, 5, 10, sometimes 20 minutes, depending on what services she was using. And I'm sure some of you, like if you use cloud, you understand, depending on what kind of service you're using or what services you're using, it can take upwards of 10, 15 minutes to get like everything spun up and bootstrapped so that but you could even see your application running. what she said is it felt like sending a text and waiting 10 minutes for the reply. And then like you see the person typing in the little bubble typing. And I could totally relate. That really frustrates me. It grinds my gears because I'm like, I sent this to you, especially if it's like something quick that I want some like quick feedback about, and it takes forever to get feedback. It just grinds my gears. So for Maya, that not only killed her momentum, but it left her very frustrated as well. She wasn't iterating, she was guessing. Short feedback loops are like oxygen. Without them, you don't just lose speed, you lose belief in what you're building. Imagine Figma taking 20 minutes to render a rectangle. Like every designer would rage quit Figma. That's like the industry standard. So if Figma was taking 20 minutes to render a rectangle, we'd have no more designers. Her next hurdle was the money, the dinero. Every test Maya ran hit AWS directly. Every experiment had a price tag. At one point, she even stopped building for a week because she was scared of her AWS bill. I can relate to that. I actually had a situation where I started learning cloud using AWS, and you know how you get like the free tier? I burned through that free tier so quick. It was it wasn't even funny. Like at that point, I was like, you know what? Let me put this down for a second because it's about to start costing me money. So, yeah, exactly, Jazz. You get it. Um, that's not innovation, you guys. That's a fear tax. Founders and developers alike need safe environments where they can break things without breaking the bank. And without that, creativity dies. Also, from a founder perspective, seed funding should go to hiring and growth, not mysterious S3 charges. And I'm sure I'm speaking to the choir here. Then came debugging. Maya's lambdas kept failing with vague cryptic logs. She once spent 3 days chasing what she thought was an S3 permissions bug. 3 days, guys. Turns out she was just missing an environment variable. Like that kind of thing, 3 days of wasted time, stress, and burn, that kind of thing makes you just want to give up. It makes you want to walk away. It happened to me. So, like, I'm sure it's happened to some of you guys. The lesson here is visibility is everything. Debugging clarity is the difference between iteration and burnout. Cloud error messages shouldn't feel like riddles, but yet somehow here we are. Oh, look, let me check the chat real quick. Pluralsight has cloud labs. These are open cloud playgrounds. They're AWS. Oh, that's cool. I didn't know that. I have to check that out. And yes, the facepalm moments in AWS, don't get me started. We could sit and have a therapy session about like AWS. Anyway, next temperature check. How long does your average deployment take? Is it less than 5 minutes, 5 to 10, 10 to 15, or more than 15 on average using the stack that you're using? Okay, so I've got 5 to 10 minutes, 10 to 15. Yep, so you guys are feeling the pain. You guys are feeling the pain. Who wants to sit around and wait that long? Sometimes you just give up counting. Sometimes you're just like, you know what, I'm going to deploy this. I'm going to make a sandwich and I'm going to come back. Yeah, Michael. Lambda deploys are pretty quick, but App Runner does take forever. Like I said, it's dependent on the services that you're using. Okay. So here's where Maya's story starts to shift. After weeks of failed deploys, cryptic errors, and runaway bills, she stumbles into something that she did not know existed: a whole category of tools built to emulate AWS locally. She realized she didn't have to choose between deploying straight to AWS and praying or not building at all. There was an entire toolkit out there, each with its own strengths, quirks, and limitations. So let's walk through some of the ones she tried. And a lot of times this is like the journey. Like, as a matter of fact, the community that I work with, this is kind of the journey for most folks. Um, First up, Moto. Perfect for Python unit tests. It pretends AWS APIs exist so that your tests pass without hitting the cloud. Maya loved it for her Python code base, but as soon as she needed Lambdas, S3 events, or DynamoDB flows, it fell short. Moto is a unit test hero, but it's not a full system player. Oops. Okay, next, we've got DynamoDB Local, blazing fast. And if your app is DynamoDB heavy, it's amazing. But Maya's product wasn't just DynamoDB. It was S3 because she needed S3 for file uploads, Lambdas for business logic, and queues for the background jobs. DynamoDB was DynamoDB Local was powerful, but it was just way too narrow. She also tried Server, which is a play on S3. It's a lightweight way to mimic S3 for uploads and downloads, and it's great for quick file tests. But there are no triggers, no event integration, and Maya's app needed those S3 to Lambda triggers to actually function. Then came Minio. This isn't AWS, but it's S3 compatible. It works great for object storage and in Docker or CI pipelines. But again, Maya's problem wasn't just storage. It was the workflow across multiple services, and Minio could only solve part of it. She also tried Sam Local, which let her run Lambda functions on her laptop and pass in events, which is perfect for quick function level testing. But it stopped there. Maya needed to see her Lambda in context, which included being triggered by S3 and writing to DynamoDB. And it all needed to be tied into her whole workflow. So she found LocalStack. And this one could emulate over 80 AWS services on her local machine. And she could spin up her entire workflow, S3 to Lambda to DynamoDB to SQS, all local, all fast, and no AWS built. Now, the trade-off here is it's a little bit heavier to set up than some of the lightweight single service tools. But for Maya, this was the first time she could see the whole picture locally. So this was her turning point. She had finally found a safe way to build, test, and debug without burning time or burning that bag. And y'all know time is money. So if you burn in time and you burn in the bag, you burn in the bag times two. So now that we talked about the toolkit, let me show you what it looks like in practice. Okay, so let's look at a real world example. This demo app is a simple serverless image resizer. The user uploads an image. That upload event triggers a Lambda function and that resizes that image. And the resized image lands in another S3 bucket ready to be displayed in the app. Pretty straightforward, but under the hood, it touches multiple AWS services. And it's exactly the kind of workflow that Maya was trying to replicate now. So Maya wasn't doing a serverless image resizer. but she was, you know, working with different services in a workflow. So let's take a look at what that looks like. Let me make sure my screen. Okay, cool. Do you all need me to, can you all see my code in my terminal properly, or does it need to be a little bit bigger? Okay, sweet. Awesome. Okay, so what we're gonna do here is we are going to run an entire AWS workflow on our laptops, you guys. So we're gonna start by, so this is our serverless image resizer, just to clarify. We're gonna start by deploying our application. Let me make sure LocalStack is running, by the way. It is. Sweet. Okay, so let's deploy our workflow. And what you see happening here is LocalStack spinning up all the AWS resources that it needs locally. So first, let's go up. So we've got our two S3 buckets, one for our original images and one for the resized versions. Then we've got an SNS topic for error handling. Think of it as like a channel where failed resized jobs get published. Then we've got 3 Lambda functions. Let me find. So we've got our pre-sign function, which generates upload URLs. We've got our list function here, which lists our images. And then we've got our resize function, which resizes an image when a new one hits the bucket. And finally, we've got our static web app front end that gets dropped into an S3 bucket, a third S3 bucket, and it gives us a simple UI that we can upload and view images. And we will look at that now. All right. Okay, so we are going to load our function URLs so that we can make this thing work. And in the browser, like I said, you guys, we're running this all locally. We're not hitting AWS at all here. In the browser, we're going to upload an image. So we'll start by uploading. Oh, we'll choose our file. Got to do that first. We'll start with the AWS logo. And we'll upload it. Okay, we got our success message. All right, so we've got our original and then our resized. Now let's look at our LocalStack UI. So behind the scenes, what happened is S3 triggered the resize lambda, which output the resize image to the images bucket. And everything worked exactly like it would in AWS, except it's running on my laptop. So here, we're looking at the LocalStack UI. You can see S3 buckets, which we'll point out here. So we've got our 3. We can go back and see our lambdas. We've got our pre-sign list and resize. And we can go to SNS and see our SNS topic. And that's the one we saw, our failed resize SNS topic. But let's go back to our S3s and see. So we've got our original S3 bucket, which has our original image in it. And then we also expect to see our image in our resized S3 bucket, which we do. So that means our entire workflow worked properly. So happy paths are great, you know, but they're not the problem. So let's break it. Like, let's change the Lambda handler to something that doesn't exist, and watch what happens. Let's go back to our code. Okay, this way. Okay, so what we're doing here is we are pointing our handler to handler.this does not exist. If you could see that. Actually, you probably cannot. All right, so it says yes. Handler dot this does not exist. This is not an existing handler, unless that's not already clear. And so what we're gonna do here is we're breaking it. And when we try to upload again, it's gonna crash. And it'll go straight to our SNS topic, just like it would in production. So let's go back to our UI here, and we're gonna choose another image to upload. Let's use a step functions logo. So this is going to fail, even though it gives us a success message, which is a part, like it's a part of it. So we'll see, we don't see our resize image. We do see that there's a size for our original image and there's nothing for our resize image, which was by design. Let's go and look at our S3 bucket. So we've got our original image. Let me refresh. So now we see two images in our original bucket. This is not our resize bucket. Let's go to our resize bucket. We only see one, which is by design. That means that our workflow broke. But notice we didn't get a clear error message here. Like, as a matter of fact, let's look. Let's inspect and see what we even got. Did we even get anything? Oh, we got a fail to load resource. The server responded with a status of 403. So yeah, we didn't get anything anything real. So this is where folks like Maya or the rest of us would spend time in AWS, like digging through logs, trying to figure out what the heck happened, because we didn't get any issues. Now let's go and check our SNS topic to see if that actually, if we have a message here. Oh wait, no, we'll be on SES because SNS goes to SES. So let's see if we've got. Oh, we don't have an email here. That's interesting. Okay. Oh no. So let's refresh here. So we've got currently our working workflow and then our crash workflow. Cool. Now let's see how quickly we can fix this. One quick CLI call to point the Lambda back to the correct handler. Code goes this way. And we'll be fixed. So right here, I'm going to point the handler back to the correct handler, handler.handler. Push that. And so we might get a situation where it takes the UI a couple of moments to like catch up with us because we are running this locally. But let me try uploading this third image here. And if it doesn't like show up right away, we'll refresh it and it should show up. So we've got a success. We got it right away this time. Awesome. So we fixed our workflow. And you see how quick that was. Like a lot of times, I guess like we talked about earlier, we have all of these long deploy times that take us, 15 or so minutes to get back working once we've hit a snag and had to debug. Let's have a look at what it looks like on our LocalStack UI. So let's go back to S3. All right. So we should see 3 images here, which we do. And let's go back to our resized and we should see 2. There we go. So that means our workflow worked as expected. All right. So we fixed it. Now, so far what we've done is we've uploaded, we've broken our workflow, we fixed it, and now let's test. All right. So we've got a test here, an integration test that not only tests the happy path, but also a failure case. So our happy path, which is here, uploads an image, Lambda runs, the resized image appears, and the test asserts that the resized image is indeed smaller than the original image. And our failure path, our failure case says it uploads a non-image, so it's going to upload a text file. Our Lambda fails, our SNS notification is published, and an SCS email is mocked by LocalStack, and it's verified. This isn't just about checking if the code runs, you guys. This is about validating the failure modes also and confirming that your observability and error handling actually work the way that it's supposed to. So all we'll do here is run, So all we'll run here is PyTest. And we're gonna just put it on our tests folder. So this is gonna run this test. All right, and our test passed. So this is where Maya's approach completely changed. So instead of pushing code to AWS and hoping for the best, she could fake the cloud locally and spin up her entire system on her laptop like we just did, break it on purpose, and watch how it behaved. That shift is everything. No more deploying and praying, just confident shipping. All right, let's go back to our slides. Okay, so what did we learn from Maya's journey, guys? We learned that short feedback loops keep you moving. Safe environments protect your creativity and your budget. And debugging clarity saves time and sanity. And also that local simulation builds confidence before you ever hit deploy. And these principles help Maya and they can help the rest of us too. So why fake it till you make it? Because that's exactly what Maya did. She didn't have to use AWS directly every time and bleed money just to test an idea because she was able to fake it on her laptop. By faking the cloud with local emulation, she could build fast, break things safely, and fix them without waiting on long deploys or surprise builds. And once she had that foundation, she made it. Um, she launched her V2 product with confidence. And that, folks, is what's at the core of Fake It Till You Make It Cloud Edition. Fake the cloud first, then make it in production. And thank you all so much for joining. Maya's story is just one example. I know plenty of us have lived through your own fake it till you make it cloud moments. If you want to try this out for yourself, scan this code to get the sample app repo. And it's also, well, I think this one actually just takes you to the sample app repo. And let me know if you all want, well, actually, I have another link that gives the sample app repo and also some docs as well. So as a matter of fact, before I open it up for questions, I will put that on the screen. So that way, it's this one here. If you do that, my link tree, go to BITCON Talk Resources, and you'll get everything that you need. But what questions do you all have? Let me check the chat. Is LocalStack only for AWS, or does it simulate GCP and Azure as well? Currently, it's only for AWS and Snowflake, guys. Azure is coming. GCP is not on the roadmap yet, but it's possible. Just like it's really going by demand. AWS is like kind of industry, like the industry leader. So that's what LocalStack decided, to tackle first. And so Michael, you're familiar with LocalStack? Yeah, it has gotten better over the years. It was a little clunky at first. I definitely have seen that feedback, and it has been heard and remedied for the most part. There's still some parity issues, but for the most part, like especially with the core, especially like your core serverless stack, like you're rocking and rolling. Yeah. Another question that I normally get. Oh, yes, you said it used to be hard to debug your app. Was it the app or LocalStack? That's the question. That is a good question. I do not have an answer for you, but like, is it the app or is it LocalStack? That is, there you go. One of the questions I normally get is, can you use this in CI? Short answer, absolutely. You can absolutely use this in CI. As a matter of fact, if you're using GitHub Actions, there is a LocalStack action that, like, it's a headless version of LocalStack that you don't even need to have AWS for, and you can just run that in your CI, easy peasy. Just make sure that you put it to that LocalStack action. Any other questions? Oh yeah, no, it's not the case anymore. Back in the day, you talking about, right? It used to be you trying to figure out whether your app was the problem or LocalStack. Yeah, not so much anymore. It's actually a pretty solid product. A lot like a couple of different use cases that I have encountered in the community are folks that were building or they're building for the cloud maybe the first time and not wanting to hit AWS like for their build cycles. So they would use LocalStack to get their entire application built. And especially if they're using serverless, I think serverless is the best use case personally. But when it's time to actually deploy it and actually start getting people to use it in real life, then they would actually deploy to AWS, because the lift and shift is literally like 1-to-1 for a lot of these services here. So it's like you can, as long as you, instead of pointing to LocalStack, you'll point to actual AWS. It's that simple. And if there are no additional questions, thank you all for coming to my talk. And if you want to find me on social media, if you use this QR code, you absolutely can. And I'm open for questions that you might have after the fact. Or if you just want to connect and talk cloud and, talk shop about other things, I'm available there too. Awesome. Thank you all for coming to my talk. And until next time, bye.